In this video, we are going to discuss ionic compounds. Now, ionic compounds are made of ions, and ions are charged atoms. So, they become charged by gaining or losing electrons. So, atoms become charged by gaining or losing electrons. So, let's look at this a little bit more specifically. Atoms are going to become charged when they gain or lose electrons. So when an atom loses one or more electrons, it is called a cation. Notice it still has the word ion in it. The cat part of it tells us that it is going to lose electrons. And since it is losing electrons, it's going to have more protons than electrons. Overall, it is going to have a positive charge. So cations are going to be positively charged ions. Now, when an atom gains one or more electrons, it is called an anion. Now, when it gains electrons, it's going to have more electrons than protons, so it is going to have an overall negative charge. An ionic bond happens when you have the positive, negative, attractive forces between a cation and an anion in a compound. So the big thing here is there is no sharing of electrons. So that's the big difference between covalent and ionic bonding. Ionic bonds happen from a full transfer of electrons. And that full transfer of electrons results in a positive or negatively charged ion. And the positive, negative attractive forces are what hold the ionic bond together. The ions in an ionic compound are held together in a very fixed pattern. It is a long range pattern called a crystal lattice. So they have very rigid structures that the pattern happens over a long distance of space, if you will. And for that reason, all ionic compounds are solids at room temperature. So here are some examples of different types of ionic compounds. Notice there can be a full range of colors. And I do want to write down that all ionic compounds are solids at room temperature. So let's look at naming ionic compounds. Now, when you're naming ionic compounds, you simply name the cation and then you name the anion. So the cation is going to be a metal, and that is very important. Cations will always come from a metal, anions will always come from a non-metal. And so when you're naming the cation, it's just going to be the name of the metal. When you're naming the anion, it's going to be similar to what we did with the covalent compounds. You're going to take the non-metal name and change the suffix to "ide." There are some things that you need to realize about these different ions. So, the charge of an ion is indicated as a superscript following the atomic symbol. So for main group elements, remember that's going to be the S block and the P block. To determine the charge is really easy. So group one is +1, group two is +2, and then skip all of the transition metals over to group three, and group three is going to be +3. Now, this fourth group right here, it doesn't really participate in ionic bonding, so we don't really know the charge of it by looking at the periodic table. Now, after that group, we get into the negatives. So it's going to be -3, -2, -1. I do expect you to know the charges of these main group elements. Notice that the noble gases have an overall charge of 0. They do not have a charge. All right. This also tells us that these are all metals. They are all going to have a +3 charge, or they're all going to have positive charges. They're all going to be cations. Here, the negative charges, we can include arsenic actually, or only going to include these. Bismuth is a metal, so it's not going to have a -3 charge. No way. All right. It's going to have a positive charge because it is a metal. So for the anions, just look at the non-metals. So let's look at a simple way to predict the chemical formula. A simple way to predict the formula of the compounds with different charged ions is to cross the charges. Now you do have to be careful with this because ionic compounds will always have the simplest formula. So here, in this example, calcium is in group 2. It's going to have a 2+ charge. Phosphorus is in group 5. It's going to have a 3- charge. So we can simply cross the charges to get our formula of Ca3P24. What you're really doing here is the overall charge of an ionic compound must be 0. It must be charge neutral. So what that means is the overall positive charges must equal the overall negative charges. All right, so if I have calcium with a 2+ charge and phosphorus with a 3- charge, I need to make it so they are equal. Not the charges, but the overall charge. So if I have 3 calcium, like what we saw here, that's going to give us an overall 6 positive. If I have 2 phosphides, that's going to give us an overall of 6-, so our total charge is going to be 0. So notice I do not have a charge on my ionic compound. Now let's look at naming this. If we looked at our rules, we just take the metal name of the cation. So this is going to be calcium. And then I'm dealing with phosphorus, but I'm going to drop the suffix and add "ide." So this will be phosphide. There we go. Now, the big difference between covalent and ionic compounds with naming it, notice I didn't indicate how many of each atom I have. So ionic compounds have what are called fixed formulas. Because they're held together by the positive, negative, attractive forces, and because it needs to be a charge neutral compound, there's only one way that calcium and phosphorus can come together. They can only come as Ca3p2. So since there's only one way, I don't have to show how many of each atom are present or how many of each ion are present. That's not true with covalent compounds. If I have carbon and oxygen, I can have a lot of different ways that they can come together and share electrons. So that's why we have CO, carbon monoxide, or CO2, carbon dioxide. In those cases, I have to indicate how many of each atom are present because there can be a different amount. With calcium phosphide, I can't have a different amount that are present. It has to be the same thing all of the time. Now, what we just learned about are called monatomic ions. Monatomic ions are exactly what it sounds like. Mono is one, so it's made up of a single atom. Now, we also have polyatomic ions, and that is where we have two or more atoms that are covalently bonded and they have an overall ionic charge. So you do not need to memorize the polyatomic ions. They will always be provided for you on a quiz, but you do need to know how to use them. So let's get some practice with naming ionic compounds. So determine the name for the following ionic compounds. So for these, I just have to identify my cation, name the cation, and then identify my anion and change the suffix to "ide." So for this first example, I have potassium and I have fluorine. So, excuse me, this is going to be potassium fluoride. It's just as simple as that. In this next one, I have magnesium and sulfur. So I'm going to name this as magnesium because my cation is just the name of the metal. And then sulfur becomes sulfide. Now, in this next one, I notice that both of my metals are calcium. However, I have some polyatomic ions. So if I look at my previous table, I can find PO4, and the name of that is phosphate. So I'm just going to put that as my anion name. Monatomic ions end with "ide." Polyatomic ions do not end with "ide." So this is going to be calcium phosphate. Notice that I just left the word phosphate alone. I didn't have to change anything to it because that is the name of the ion. The name of F is fluorine. Now, I have to differentiate between these two things because they have very different physical and chemical properties. So when that becomes a -1 charge, I now have fluoride. So those are two very different things that have to have different names. The name of PO4 with a 3- charge is phosphate. So I can just put the name phosphate there. Notice that that phosphate still has a 3- charge. However, it's in a compound, so we don't write the charge anymore. We just write the ion. And those charges are being balanced through the chemical formula. Now, in the next one, I still have calcium. And then I see that I have a polyatomic ion because I have nitrogen and oxygen within that ion. So I can go back to my polyatomic ion list, find the NO3, and I'm dealing with nitrate. So this next one is going to be calcium nitrate. Go ahead and pause the video and see if you can determine the formulas for the following ionic compounds in the next problem. All right, how did you do? Now, determining the formulas are a little bit trickier. So you're going to really have to become best friends with your periodic table. So in this first one, we have calcium nitride. So calcium is Ca. It is in group 2. So I know it's going to have a Ca with a 2 plus charge. Nitride is nitrogen. It is in group 5, so it's going to have a 3 minus charge. Now I can use the cross charge method, which means I'm going to put the 2 with the nitrogen as a subscript and the 3 with the calcium. So I will get Ca3 and 2. Now, since I have 3 calcium, it means I have 3 things with a positive 2 charge. That's going to give me an overall 6 plus charge. Since I have 2 nitrogen, I have 2 things with a 3 minus charge. So that's going to give me an overall negative charge of 6. So those cancel each other out. For this next one, we have sodium. Sodium is in plus 1. Sorry, I just gave it all away. Sodium is in group 1, so it is going to have a plus 1 charge. If I go over here, hydroxide is not an element. So that tells me that it's probably a polyatomic ion. So I can find hydroxide, and here is the formula for hydroxide. So I can write that over here. It is OH with a minus 1 charge. Now notice that the charges are already equal. They are plus 1 and minus 1, so I can just rewrite this as NaOH. All right, let's look at this next one. We have magnesium. Magnesium is in group 2. It's going to have a 2 plus charge. Sulfate. This has an ending in 8, so I know that it cannot be a monatomic ion. So I can go to my polyatomic ion table and I can find sulfate. And here is the formula for sulfate, SO4 2 minus. Here again, I don't need to use the cross method because the charges are already equal to each other. So I can just rewrite this as MgSO4. Now, something I want you to be aware of is if your charges are not equal and you're dealing with a polyatomic ion, similar to what we have with calcium and phosphate, calcium is a 2 plus charge, phosphate is a 3 minus charge. When we use the cross method here, you have to say there's 2 of the entire thing. So in order to do that, we use parentheses and you put the 2 outside of the parentheses. Notice I did not put P2O4. That changes the identity of the substance. I no longer have phosphate. So I have phosphate, and since I need 2 of them, I put a 2 outside of the parentheses. All right, let's look at our last example. We have aluminum, Al. Aluminum is in group 3, so I have a 3 plus charge. And then we have oxide. Oxide is oxygen, and it has a 2 minus charge. It is in group 6. So if I use the cross method here, notice the charges are not equal. So I can't just say there's one aluminum and one oxygen because that would not give me a charge neutral compound. So I'm going to have 2 aluminum. We can cross the 2 over here. Notice that when I'm using the cross method, I don't take the charge with it. I only use the number. And then we can write our oxygen, and we're going to have 3 of those. Now, when you are naming these different compounds, or you're taking the name and getting a compound, it's very important that you can differentiate between whether it is an ionic or a covalent compound because they have different rules. So on this slide, we can get some practice with identifying whether something is an ionic or covalent compound. The easiest way to do this is look for a cation. Now, for this class, that is either going to be a metal or the polyatomic ion NH4 plus. If you go over to our table, you'll notice that most of the polyatomic ions are negatively charged. And then we have ammonium. Ammonium is a positively charged polyatomic ion. So if you were to name something with ammonium in it, you would just use the word ammonium and drop the word ion. So you can go through this table here, this practice problem here, to identify whether this is going to be covalent or ionic, and then I encourage you to name them. If you email them to me with whether it's a covalent or ionic compound and its name, I will give you some extra credit. All right. The last thing we're going to talk about in this video are diatomic elements. So, to most people, salt means just really just table salt. Now, to a chemist in a science lab, the term salt refers to any ionic compound. So, table salt is NaCl. For this class, we are not using common names, we are using IUPAC names. So if you see NaCl on a quiz or a lab, then you will name it as sodium chloride. In our everyday life, we would probably just refer to it as salt. So here are some other common names: lye, which is sodium hydroxide; water, which is H2O dihydrogen oxide; alcohol, which is C2H5OH. All right, so just keep in mind that when you Google these different structures, the name that you get might not be the IUPAC name. So make sure that you know how to name these using IUPAC nomenclature. Now, there are certain elements that do not exist by themselves, and they are called the diatomic elements. So the diatomic elements are hydrogen, nitrogen, oxygen, fluorine, and then we have chlorine, bromine, and iodine. So there are 7 diatomic elements, and they are held together through a covalent bond. Now, when you're naming these, we do not name this dihydride because it is a diatomic element. We just name it as hydrogen. And it's the same with all 7 of these diatomic elements. You do need to know the diatomic elements. There are a number of different ways you can learn them. I like to just use the periodic table. So I have hydrogen as 1, And then I go over to nitrogen and just make a 7 down to iodine. So those are your 7 diatomic elements.